Alright, so the other part of exponential growth and decay is being able to make an equation from a table. So here, the basic form of an exponential function is y equals a times b to the x. Okay, we know we have an h and a k, but we're going to assume that there's no shifts here. Okay, so what this wants us to do is kind of look at an equation and write the table and try to see a pattern between the a and the b value. Okay, so these just want us to type it in the calculator and see what these values are. I will type a few in the calculator, but then I'm going to do some by hand. So for example, this first one I'm going to do by hand by plugging in, but as we start getting to these decimal ones, I will plug those in the calculator. Okay, so here if we plug in 0, anything to the 0 power is 1, so 3 times 1 is 3. So this one's 3. If I plug in 1, 2 to the 1, so here 2 to the 1 is 2, times 3 is 6. 2 squared is 4. 4 times 3 is 12. 2 cubed is 8. 8 times 3 is 24. And 2 to the 4th is 16. 16 times 3 is 48. So here we're just going to identify the a and the b values and see if we can figure out what the pattern is. And actually, let me just come over here and do all of them, or all the ones I can do by hand, and then I'll do all the calculator ones, and then we'll try to see the pattern. Alright, so if I plug in 0, that's a 1 times 2 is 2. If I plug in a 1, that's 3 times 2 is 6. If I plug in a 2, 2 squared is 9. 9 times 2 is 18. 3 cubed is 27. Times 2 is 54. 3 to the 4th is 81. 81 times 2 is 162. Okay, plugging in these. 0, anything to 0 is 1. Anything to the first power is itself. 6 squared is 36. 6 cubed is 216. And this one you might need a calculator for, or you might not need it for that one. But 2 to the 4, or 6 to the 4th is 1,296. Alright, here. Again, if I plug in 0, anything to the 0 is 1. So 1 times 8 is 8. To the 1 power is itself, so this is half. Half of 4, or sorry, half of 8 is 4. If I square it, 1/2 squared is 1/4. 1/4 of 8, or 8 divided by 4 is 2. If I cube it, I'm going to get 1, or I'm going to get 1/8 here, times 8 is 1. And then if I raise it to the 4th power and then multiply by 8, I get 0.5. So hopefully by now you're seeing the pattern of what's happening. But we'll come over here in the calculator and do those other ones. So we want the table for E and F. So we're going to do y equals 100 times 0.5 to the x power graph. And we're looking at the table for this one. So Control T. At 0, we have 100. At 1, we have 50. At 2, we have 25. And at 3, we have 12.5. There's actually a 4 down there. It's just I can't see it in this picture. Okay, so then the last table here. Actually, I don't want control. Let me see, tab. Okay, and then here is the 200 times 0.8 to the x. So at 0, it's 100, or sorry, I need to go to 0. At 0, it's 200. At 1, it's 160. At 2, it's 128. At 3, it's 102.4. And at 4, it's 81.92. I just can't see it here. Okay, so what it wants us to do is see in the table where we can find the A value and where we can find the B value. So let's go through all of these and say what's A. So here A is 3, A is 2. Here there's not a number in front of 6, so then we say there's a 1 there. Here A is 8. Here it's 100. And here it's 200. Okay, and then all the B's are your bases. So B here is 2, 3, 6 is the base, 0.5 is the base, 0.5 here, and 0.8. Now before we start trying to figure out the A and the B, if you look at them, we can already say if it's growth or decay. So here, since the base is more than 1, and these are going up, so these are going up and these are going up, this is a growth. This one, these are going up, these are going up, the base is more than 1, so you always look at the base. This one's a growth as well. Here, 6 is your base and the increase, so growth. Here, the base is less than 1, so these are going down, they're decreasing. So we say this one's decay. The base is less than 1, so again, decay. Notice all the A values are not negative, they're all positives. So here, 0.8 is also decay. Okay, so now let's see on all of these, where can we find the A value? So the A is where in all these equations. So here A was 3 in the table, we see that it's right here. Here A was 2. Here A was 1. Here A is 8, 100, and 200. So the A value, and that it has this at the bottom, but I'm going to write over here. So the A value in the table is always the y-intercept, where x is 0. Okay, don't say it's always the first one, because that's not true. It happens to be the first one here, because they all start at 0. But if it started at negatives, if it started at 3, you would have to go to 0. So it's always the y-intercept. B, so notice 2 is nowhere in the table. But how do I get 2? Well, to go from here to here, I have to multiply by 2. To go from here to here, multiply by 2, multiply by 2, multiply by 2. So the common ratio is where I get the base from. So here, this one should be 3. To get from here to here, I multiply by 3, by 3, by 3, by 3. So all the way down. Here should be 6, by 6, by 6, all the way down. So the common ratio, so B, to get B value, that's going to be the common ratio between your tables. So from here to here, yes, you can say you divide by 2, but we don't write divided by 2 in the equation. We write multiply by 1/2. So dividing, because this is always a multiplication equation, you put it as multiplying by a fraction. So here, yes, 100, you take half of it to get 50, half again. So you're multiplying by 1/2, which is 0.5. Here, to go from there to there, well, this one's not so easy to figure out. So this one you might divide. You might need to divide 160 divided by 200, and you'd get the 0.8. So you're multiplying by the 0.8. So if you're not sure what the common ratio is, then work backwards. Divide the bottom up. So 160 divided by 200 would give you the 0.8. Okay, so now what I want you to do is, using a table, or given a table, you should be able to make the equation from that table. So over here, and I really don't even need to see the whole table because it's telling me it's an exponential function. So I know it's going to be the same ratio. I just need to get a couple of numbers. So here, to find the a value, that's your y-intercept. Because we're going to see this on the next unit, this is your starting point. This is where the graph starts on the y-axis, your initial value. So for these, the y-intercept is 0.5, or sorry, is 5. So the 5 would be your a here. And your y-intercept is 2. So your a would be 2 here. Times the b value is the common ratio that you get when you divide consecutive numbers. So here, if I divide 20 by 5, 20 divided by 5 is 4. Here, if I divide 80 by 20, 80 divided by 20 is 4 again. So they're all going to be 4 because it's exponential. So that means my common base is 4. So that's the b value. So the equation I would write here is y equals 5 times 4 to the x. And then here, since the y values are increasing, I know this is a growth. So y values increase when it's exponential growth. So here this would be a growth. We're going to run into some decreasing ones. If it decreases, then it's exponential decay. That means your base is going to be more than 1 here, and then the base is less than 1 here. Alright, so looking at the next one. Again, you can also ask yourself, what do I have to multiply 2 by to get 18? Well, I have to multiply by 9. But the bigger numbers, you might not know exactly what to multiply by, so then you work backwards. 162 divided by 18 is 9. So here, this one would be 2 times y equals 2 times 9 to the x. Okay, so what about some fractions? So looking at these last 2 examples, we're probably going to need a calculator for this one. So here, find the a value, find the y-intercept. So in this case, the y-intercept is 16. And in this case, the y-intercept is 500. So that's the easy part. If it's not there, then you might have to work backwards or forwards in order to see where it's 0. If you can't see the 0, then either multiply or divide. So here, what do I have to multiply 16 by to get 24? I don't know. So since we don't know exactly what to multiply by, we work backwards and we divide. So 24 divided by 16. So before I actually get that number, if you look at the y's, these are going up. So I know this is a growth, which means the b value should be more than 1. That's how you know if you divided correctly. So here we do 24 divided by 16. And it gives us that the base is 3 over 2. So if you want to write it as a decimal, you can, 1.5. But just checking another value, they're all going to be the same. But just checking another one, just to make sure we did it right. 81 divided by 54. So here, 81 divided by 54 is 3/2 again. So 3/2. This is telling me my base is 1.5. Yeah, I don't care how you write it. You can write it as fraction or as a decimal. If it's a terminating decimal, it's fine. But again, check. Since these were going up, it should be more than 1. And yes, that's more than 1. Okay, if you go backwards, you'd get 2/3, which is not more than 1. So that's how you know for sure that you divided correctly. Okay, over here, notice these values are going down. So my base, my common ratio, since it's decay, it's decreasing, should be less than 1. Alright, so coming here, I don't know what to multiply this by to get 200, so I go backwards. What do I get when I divide 200 by 500? We're going to get a decimal again. 200 divided by 500 is the fraction 2/5. So 2/5 here. And again, just checking another value. 12.8 divided by 32. 12.8 divided by 32 is, that one actually gives me a decimal because it started with a decimal. That's why it gives me a decimal here. But this is the same as 2/5. So I don't care which one you use in the formula. You can say 0.04, or you can do the 500 times 2/5 to the x. You do have to have the 2/5 in parentheses when you type it in. That and negatives, but none of these bases are negatives. For sure, fractions, make sure you put in parentheses. Okay, so the way the table works, the a value is when x is 0. The b value is whatever you get when you divide consecutive y values. The common ratio between them.